Somewhere in a museum storage room in central Turkey, there is a piece of volcanic glass. Black, smooth, sharp enough to shave with even after 12,000 years. Nobody thinks much about it anymore. It's one of thousands of similar fragments catalogued, labeled, shelved. But when researchers first started tracking where these pieces of glass actually came from, and more importantly, where they ended up, the numbers didn't make sense. This particular type of obsidian formed in a specific volcanic eruption at a specific mountain in ancient Anatolia has been found at archaeological sites hundreds of kilometers away, not tens, hundreds. And not just once, consistently at dozens of sites, across landscapes with no roads, no horses, no wheels, no cities, just people. People who somehow moved this stone farther than anyone had any obvious reason to expect. That's the mystery sitting at the center of this story, and it's one that researchers are still quietly arguing about. Here's what makes obsidian strange as an object of study. It's heavy, it's fragile, you can't eat it, it doesn't keep you warm. It has no obvious reason to be in the archaeological record 400 kilometers from the nearest volcano that could have produced it. And yet again, dig after dig, the stuff keeps turning up where it shouldn't be. In coastal settlements, nowhere near volcanic islands, on islands that were never volcanically active, in villages whose inhabitants had perfectly usable local stone right underneath them. Someone, or more likely many someones, over many generations, decided this particular glass was worth moving, worth trading, worth the effort of carrying it across mountain passes and river valleys and stretches of open sea. The question that drives this whole investigation is deceptively simple. Who connected the Stone Age world? Not in some grand civilization building sense. There were no empires here, no merchant guilds, no written contracts. But connection happened anyway. Somehow communities that had never heard of each other, that had no shared language we can reconstruct, that had no concept of trade in any formal economic sense, still ended up sharing materials across distances that feel almost impossible for the time. How do we even begin to understand that? And how would we know it was happening if the people involved left no writing, no maps, no records of any kind? The answer, it turns out, is locked inside the obsidian itself. And that's where this story gets genuinely interesting. We're going to move through this slowly and carefully because the evidence deserves that kind of attention. There are maps to look at. There are competing interpretations. There are moments where the data is solid and moments where researchers are guessing, and it matters to know which is which. If you're the kind of person who likes to fall asleep to something that actually goes somewhere, something calm but curious, something that treats you like you can handle a bit of ambiguity and nuance, then you're in the right place. And speaking of where you are, if you're already drifting somewhere comfortable, listening to this at midnight in Auckland, or early morning in Edinburgh, or on a lunch break in São Paulo, drop a comment and let me know. Seriously, where are you and what time is it? I read through those comments and it never stops being a little bit wonderful to see how scattered across the planet people are all listening to the same quiet question about Stone Age trade routes at completely different hours of the day. There's something almost appropriate about that, given what this story is about. Also, if you listen on Spotify, go ahead and follow the show there. It's Adri. No background music, just the story, exactly as it's meant to be heard, and it helps keep this going. Link is in the description. Now, back to the obsidian. What we're dealing with here is a thread of evidence stretching from the Paleolithic, which is to say the Deep Stone Age, the era before farming, before villages, before anything you'd recognize as settled human life, all the way through the Neolithic, the period when people began cultivating crops, building permanent settlements, and organizing themselves into something more complex. And across that entire sweep of time, obsidian keeps moving. The distances change, the patterns shift, the scale accelerates. But the basic fact of long-distance stone movement never goes away. It just gets harder to explain the longer you look at it. There are researchers who think this represents formalized exchange networks, people trading deliberately, building relationships across distances through the movement of materials. There are others who argue the evidence is more ambiguous than that obsidian could have moved hand to hand over generations, through a kind of gradual drift, nobody ever carrying it very far, but the cumulative effect being these enormous distances. And there are still others who think the answer probably varies depending on the period, the region, and the specific communities involved. That's a more complicated picture, but it's probably also a more honest one. What we can say with confidence is this: long before the first city was built, long before the first writing system was invented, long before anyone had a word for commerce or a concept of a market, human communities were moving objects across landscapes in ways that required either sustained effort, sustained relationships, or both. The obsidian is the proof. The fingerprinting techniques that let us trace exactly which volcano a piece of glass came from are the key that makes the proof legible. And the maps that result from all that analysis are genuinely some of the most quietly astonishing things in all of prehistoric archaeology. We'll get into how all of that works: the chemistry, the sourcing techniques, the specific routes that scholars have been able to piece together across Anatolia, across the Aegean, through the Levant. We'll look at what the evidence suggests about how ordinary people in the Stone Age understood their world and their connections to distant places they may never have visited themselves. But for now, just sit with the image. A piece of black volcanic glass, impossibly sharp, impossibly far from home, waiting in the soil for someone to find it and ask the right question. Someone moved this, and we're still working out why. Start with the most basic question, the one that needs answering before any of the trade routes or fingerprinting or ancient maps make any sense. Why obsidian? Of all the things people in the Stone Age could have moved across difficult terrain, why did this particular material keep showing up far from home? The answer begins with geology, and it's more interesting than it might sound. Obsidian is volcanic glass, not a metaphor, not a poetic description. Actual glass formed when silica lava cools so rapidly that its molecules don't have time to arrange themselves into crystals. The result is an amorphous solid, structurally closer to a frozen liquid than to what we normally think of as rock. And that unusual structure is exactly what makes it remarkable as a tool material. When you strike most stones, they fracture unpredictably along grain boundaries and crystal planes. Obsidian has no grain boundaries, no crystals. So when it breaks along what's called a concidal fracture, a smooth, curved surface that follows the force of the blow rather than the internal structure of the material. This means a skilled knapper, someone who knows how to work stone, can control the break with precision that no other natural material quite allows. The edges that result from that fracture can be genuinely extraordinary. Under electron microscopy, a well-knapped obsidian blade has an edge measured in nanometers, thinner than a human red blood cell, sharper than surgical steel, not marginally sharper, dramatically sharper, in a way that matters when you're trying to butcher an animal efficiently, or cut plant material, or do any of the hundreds of fine tasks that daily life in the Stone Age actually required. Experimental archaeology has confirmed this repeatedly. Obsidian blades cut more cleanly, require less force, and stay sharp through longer use than comparable tools made from flint or chi. Modern surgeons have occasionally experimented with obsidian scalpels for procedures where a minimally jagged edge matters for healing. The Stone Age wasn't using an inferior substitute for something better. In many respects, obsidian was the best cutting material on Earth until the development of high-quality metallurgy thousands of years later. The practical toolkit that obsidian made possible was genuinely varied: blades for cutting, points for hunting, scrapers for processing hides, fine engravers for working bone and wood. Each of these required slightly different knapping technique, slightly different edge geometry, and obsidian accommodated all of them. A good piece of raw obsidian, properly worked, could yield a remarkable number of usable tools. Some Neolithic workshops show evidence of highly systematic blade production. The same core reduction technique producing dozens of long parallels blades from a single nodule with almost no wasted material. This wasn't improvised or accidental. It was skilled manufacturing, repeatable and refined. Now, here's the thing. Other stones could do some of what obsidian did. Flint, pitch, and quartzite were all worked by Stone Age people across the ancient world, and they could produce serviceable cutting edges. If you were in a landscape with good flint deposits, you weren't helpless without obsidian. You could hunt, process food, make clothing, do most of what daily survival required. So, the presence of obsidian at sites hundreds of kilometers from the nearest source isn't simply a matter of raw necessity. People weren't moving it because they had no alternative. They were moving it because it was better, different, worth the effort in some way that went beyond simple functionality. And this is where the story gets more complicated and more interesting. There's a meaningful distinction between the way people collected local toolstone and the way they acquired obsidian from distant sources. For ordinary stone, the pattern looks like what you'd expect. People collected flint or CH when they were near a good deposit, used it, left debris behind. The material shows up in archaeology close to where it naturally occurs, with concentrations dropping off fairly quickly as you move away from the source. The effort involved was modest. You picked up stone when you walked past it. Non-local obsidian doesn't behave that way in the archaeological record. It shows up at sites where there is no nearby volcanic source. It shows up in quantities that suggest deliberate, repeated acquisition rather than occasional finds. It shows up in forms that sometimes indicate it was being transported as pre-prepared cores or finished blades rather than raw nodules, which implies decisions were being made about how to move it efficiently. Someone was thinking about the logistics of getting this specific material from a specific place to a specific destination. That's a fundamentally different kind of behavior than picking up a convenient rock while walking through a valley. So why would anyone go to that kind of trouble? The practical value is part of it. Almost certainly, if you're a hunter, and obsidian points are meaningfully more effective than your local alternatives. That difference compounds over a hunting season. Better cuts on butchered animals mean more usable meat from each kill. Finer scrapers mean better processed hides and warmer clothing. The performance advantage is real, and it accumulates if you have access to obsidian. You're slightly better equipped for survival in ways that matter day to day. That's not a trivial motivation. But there's something else obsidian offers that purely functional materials don't, and it would be a mistake to ignore it. Obsidian is beautiful. Not in a soft or gentle way. Beautiful the way a night sky is beautiful. Black or deep brown, sometimes banded with subtle translucency, catching light differently depending on the angle. Polished surfaces with a depth that no ordinary stone has. When you hold a well-made obsidian blade, you know immediately that you're holding something unusual. Something that didn't come from around here. Something that required knowledge, skill, and access to places most people had never been. Across many human cultures and many different periods, materials that are scarce, visually striking, and associated with distant or difficult-to-reach origins have served as markers of connection and social distinction. Not necessarily in a crude status display sense, though that happens too. More subtly, exotic materials signal relationships. They say, I have connections to people or places you don't have access to. They say, I received this from someone. And that exchange created an obligation, a bond, a story that gets told. The object carries social information as well as physical utility. And in small communities where relationships are everything, that kind of information matters enormously. Some researchers are cautious about applying these ideas too freely to prehistoric contexts, and that caution is reasonable. We can't ask anyone who used this material what it meant to them. We can observe that obsidian was sometimes found in contexts that suggest special treatment, buried with individuals concentrated in particular locations, worked with unusual care. But interpreting what that special treatment meant involves inference, and inference has limits. The honest position is that obsidian probably carried practical value and social value simultaneously, and that the balance between those two dimensions likely varied by community, by period, by the specific uses the material was being put to. Assuming it was purely functional is probably wrong. Assuming it was purely symbolic is probably also wrong. The most useful framework holds both open at once. What we can say with more confidence is that the decision to acquire non-local obsidian, to go to whatever trouble the acquisition required, was a considered one. This wasn't material that fell into people's hands by accident. The effort involved, and as we'll see, that effort could be substantial, implies that whoever was moving obsidian across landscapes had reasons they found compelling enough to justify the cost. Whether those reasons were primarily practical, primarily social, or some blend that we'd struggle to disentangle even if we could ask directly, the movement was purposeful. It was chosen. And this matters for what comes later in the story, because once you accept that people in the Stone Age were making deliberate, effortful decisions to acquire specific materials from specific distant sources, you have to start asking how. How did they know where the obsidian came from? How did they establish the relationships that made acquisition possible? How did knowledge of a volcano hundreds of kilometers away survive in a community that had no writing? Possibly no one who had ever visited the source in living memory? These questions don't have simple answers, and different researchers argue for different mechanisms, some of them quite different from each other. But they all start from the same observation. Obsidian moved because something made it worth moving. Understanding what that something was is the first step toward understanding how the Stone Age world was, against all apparent odds, actually connected. The material itself is the starting point. Sharp enough to matter, beautiful enough to notice, scarce enough to carry meaning. That combination, practical and symbolic, useful and exotic, is what launched one of the most remarkable and least celebrated episodes of long-distance exchange in all of human prehistory. To make sense of that movement, we have to answer a question that sounds almost impossible at first. When you pick up a tiny flake of obsidian from an archaeological site, how could you possibly know which volcano it came from? It turns out the stone remembers. Obsidian is glass, but it isn't chemically simple. As the lava rose through the crust, it picked up trace elements from the rocks it moved through, and its own chemistry evolved as it set, cooled, mixed, or didn't mix with other magmas. When it finally froze into glass, that particular combination of elements was locked in place. Not just the big ones like silicon or aluminum, but tiny quantities of things like rubidium, strontium, zirconium, niobium, rare earth elements with names most of us never learned in school. In geology, those traces behave a bit like a signature. They don't give you a neat street address. This exact hillside 10 meters above the stream. But they can often tell you which volcanic system, or even which particular flow within that system, produced the glass you're holding. This is what archaeologists mean when they talk about geochemical sourcing. They're not doing magic, they're reading the frozen chemical memory of the lava. To read that memory, they need tools that can see what our eyes can't. In the middle of the 20th century, that meant packing up obsidian samples and sending them to nuclear reactors. One of the earliest and most influential methods was something called instrumental neutron activation analysis, or NAA. The basic idea sounds like science fiction. You expose a tiny piece of obsidian to a flux of neutrons, which makes many of the atoms inside it slightly radioactive. As those atoms decay back to stability, they emit gamma rays at very specific energies. Different elements produce different patterns. By measuring those gamma rays, you can work backwards to figure out which trace elements are present and in what amounts. ENA is slow, expensive, and not exactly a field technique, but for decades it produced incredibly precise fingerprints for obsidian sources across places like Anatolia, the Ayan, and the Near East. Whole reference libraries were built this way. Carefully collected samples from known volcanoes, each one measured and catalogued, forming a kind of chemical atlas against which archaeological pieces could be compared. More recently, less dramatic methods have become common. X-ray fluorescence, or XRF, uses high-energy X-rays to knock electrons around in the atoms of the sample. As those electrons fall back into place, they emit X-rays of their own, again with characteristic energies for different elements. XRF is faster and cheaper than IA. Portable XRF devices can even be brought to museums and excavation sites, letting researchers test artifacts without shipping them off or grinding off large chunks. Then there's laser ablation inductively coupled plasma mass spectrometry, LICPMS for short, which is almost as intense as it sounds. A microscopic laser beam vaporizes a tiny spot on the obsidian, turning it into a cloud of ions. Those ions are then sorted by mass in a sensitive instrument that can detect elements present at parts per million or even parts per billion. LCPME can capture an extremely detailed trace element pattern from a crater, so small you might not even notice it with the naked eye. Each of these methods has strengths and limits. XRF is relatively quick and non-destructive, but it struggles with very light elements and sometimes with extremely low concentrations. ENA is superb for certain trace elements and provides very stable results, but it requires access to a reactor and involves more destructive sampling. LICMS offers exquisite sensitivity and the ability to focus on tiny regions of a single artifact, but it demands complex equipment and expert handling. None of them by themselves say, this flake came from the northern slope of Volcano X, collected in late summer by someone named Aram. What they give you is a pattern, a list of elements and their relative abundances. The art lies in comparing that pattern to the patterns already known. This is where reference collections matter. Over the last several decades, geologists and archaeologists have hiked into quarries, clambered over lava domes, and sampled obsidian from as many geological sources as they can reach. Each sample is analyzed, usually with more than one technique, and the results stored in databases. When an artifact from a distant archaeological site is tested, its chemical fingerprint is set against this library. Sometimes the match is almost uncanny. The ratios of rubidium to strontium, the specific cluster of rare earth elements, all line up with pieces from one particular volcano and nothing else in the region. In those cases, researchers can confidently say the obsidian at this site came from that source. But the earth is messy. Not all volcanic systems are cleanly separated. Some sources are geochemically very similar, especially if they formed from related magmas or lie in the same tectonic setting. Two domes 20 kilometers apart might produce glasses that, at least with certain methods, are hard to distinguish. Weathering and alteration over thousands of years can blur the signal further, especially on surfaces. Rather than pretending that ambiguity doesn't exist, good studies lean into it. They treat sourcing as a statistical problem. Instead of asking, which single source does this artifact come from, they ask, which source is it most likely to come from, given the data we have, and how strong is that likelihood? Clusters of points in multi-element plots, probability assignments, and cross-validation with multiple analytical techniques all help researchers express not just a best guess, but a margin of uncertainty. Sometimes the honest answer is that an artifact can be assigned to a group of closely related sources, but not narrowed further. Sometimes an object seems to fall between known groups, hinting at a geological source that hasn't yet been sampled or at mixing of materials from different origins. Those cases don't close doors, they open new questions. Did people collect from multiple nearby domes? Are there buried flows we haven't found? Are our reference collections incomplete? It's also important to draw a line between two different kinds of knowledge that sourcing provides. Identifying the geological source tells you where the obsidian began its life as lava. It does not by itself tell you how it got from that volcano to the place where it was finally discarded or buried. Knowing that a blade on an iron island was made from Central Anatolian obsidian tells us that at some point the material crossed land and sea. But was it carried by one person on a single journey? Was it passed from group to group over generations in what archaeologists call down-the-line exchange? Was it moved as raw nodules, as prepared cores, or as finished tools? The chemical signature is silent on those details. To reconstruct the route, the tempo, the social mechanisms of movement, we have to combine sourcing with everything else. Site locations, settlement patterns, tool types, wear traces, radioarbon dates, even paleo-environmental reconstructions of which paths were physically possible at different times? What geochemical fingerprinting did change decisively was the way archaeologists thought about local materials in the first place. Before these methods became widespread, it was easy, almost automatic, to assume that most stone at a site had been collected nearby, unless there was some glaring geological mismatch. If a village sat on limestone and there was a basalt X, everyone agreed the basalt was non-local. But if there was dark volcanic glass in a region that had some volcanic rocks, it could be tempting to shrug and call it local, simply because there was no obvious way to test the claim. Sourcing turned those assumptions into hypotheses that could be checked. In some cases, the old intuition was confirmed. People did rely mostly on nearby deposits. In others, the picture fractured. Tools that looked ordinary turned out to come from volcanoes hundreds of kilometers away. What had been invisible long-distance connections crystallized into evidence in the landscapes we're about to explore. Anatolia, the Iron Islands, the Levant. That shift was revolutionary. Suddenly, obsidian wasn't just black glass from somewhere volcanic. It was material with an address, however approximate. And once you can point to a map and say, this stone began its journey here and ended it here, you can start asking a deeper question. What did the space in between really look like to the people who crossed it? To answer that, we need to zoom in on one particular piece of the world, a stretch of land that for obsidian works a bit like the beating heart of the old world. Anatolia. If you've ever looked at a modern political map, you know it by another name, most of what is now Turkey. But for the people we're talking about, long before cities or empires, it was a high folded plateau, framed by mountains and seas, broken by lakes and river valleys, and pierced by volcanoes. Those volcanoes are what matter for our story. Geologically, Anatolia is a mess in the best possible way. It's squeezed between the African plate to the south and the Eurasian plate to the north, with smaller plates jostling in between. That collision zone has been producing magma for millions of years. Some of it froze into basalt, some into anderite or rhyolite, and some into the dark volcanic glass we care about. When archaeologists talk about obsidian in this region, they usually think first of two broad source zones. One is Central Anatolia. Names like Goloda, Nanazida, Aceh, and the obsidian fields around Cappadocia show up again and again in the sourcing literature. This is the landscape of soft tuffs and eroded rock towers of old calderas and lava domes. Here, obsidian occurs in thick flows and scattered blocks exposed on hillsides or embedded in old deposits. For prehistoric knappers, it would have been both obvious and abundant. The other major zone lies further east in eastern Anatolia, stretching toward the highlands that grade into Armenia and northern Mesopotamia. Here you find sources like Bingal, Neid Da near Lake Van, and other complexes that have produced large volumes of glass. These eastern sources are chemically distinct from most of the central Anatolian ones, but not always from each other. Many come from magmas generated in similar tectonic settings, enriched in similar trace elements. If obsidian were rare, if there were only one or two sources in the whole region, the story would actually be simpler. But Anatolia is dotted with volcanic centers. In some areas, people could have walked an hour in one direction and found glass from one magmatic system, then walked an hour the other way and found glass from another, that to the naked eye looked pretty much the same. That overlap is where geochemistry stops being a luxury and becomes essential. On a workbench, a piece from Galuda doesn't announce itself in any obvious way. Neither does a fragment from Bingal. They're both dark, glassy, sharp. They can both be knapped into excellent blades. Without chemical fingerprinting, a tool made from eastern obsidian and carried into central Anatolia might be mistaken for something local, and the long journey it represents would simply disappear into the background. Multiple nearby sources also create another problem. Imagine a village perched in a landscape where three separate obsidian flows are technically local, each with slightly different color, fracture behavior, and chemistry. Did people prefer one over the others? Did they mix them freely? Did they reserve one kind for certain tool types? You can't answer those questions with visual inspection alone. You need to separate the stones into their geological families and then see what people did with each family. That's where assemblages come in. At an archaeological site, obsidian rarely appears as a single glamorous artifact. More often, it's a scatter of thousands of tiny fragments, raw nodules, battered cores, long thin blades, chunky flakes, snapped tips, finished tools with dulled edges, and minute chips left where someone sat and worked stone. Each piece is one point in a process that began at a volcano and ended in a hearth, a workshop area, or a grave. Raw nodules, when they're found on settlements far from the source, suggest that someone was moving unworked or only lightly tested stone. That implies one kind of exchange, perhaps groups traveling to the source and hauling back heavy loads, or specialists making dedicated trips to supply others. 'Cause the roughly shaped blocks from which blades and flakes are struck tell another story. They're lighter than raw boulders, already pruned of useless material at or near the quarry. If a site has many imported cores but few nodules, it suggests that part of the work, the wasteful early reduction, happened closer to the volcano. Somewhere out there between the site and the source, there may have been workshops, weigh stations where obsidian was roughed out before being sent on. Blades and finished tools add more detail. Long standardized blades with regular ridges along the back are hard to produce without skill and practice. If you find those blades all made from obsidian sourced to the same distant volcano, mixed in with only a few cores and almost no raw nodules, you're probably looking at a community that imported semi-finished products or even completed tools. In that scenario, obsidian wasn't just stone, it was a crafted commodity. Someone, somewhere close to the volcano, was doing the specialized work. In Anatolia, sourcing lets archaeologists line these pieces up. They can separate local obsidian from imported obsidian. They can see whether raw chunks, cores, blades, and finished tools all come from the same geological source or from different ones. They can track over time whether a site's inhabitants shifted their preferences from one volcano to another, perhaps in response to changing alliances, blockages along a route, or the rise of new communities sitting astride key passes. And this matters because of where Anatolia sits on the map. To the south lay the Levant, the eastern Mediterranean coast with its own traditions of settlement and later agriculture. Further southeast and east stretched northern Mesopotamia and the great river valleys of the Tigris and Euphrates, corridors that would eventually host some of the earliest urban societies. To the west lay the Ayan Basin and its islands, stepping stones toward mainland Greece and beyond that Europe. Anatolia is the land in between, not an isolated peninsula, but a hinge. Any obsidian from central or eastern Anatolia that appears in the Levant, in northern Mesopotamia or on Ayan Islands has crossed this hinge. It has moved along river valleys, over mountain passes, and in some periods across shorelines that looked very different from today. It might have traveled in the hands of hunters following herds, shepherds moving flocks between seasonal pastures, or early farmers seeking new lands. It might have drifted gradually from group to group, changing hands many times. Or it might have moved in fewer, larger jumps, with particular communities acting as middlemen. When researchers plot sourcing results on a map, they start to see patterns that hint at these choices. Clusters of sites that preferentially use one central Anatolian source look like the trace of a particular corridor. Places that suddenly begin to receive Eastern Anatolian obsidian at a certain time suggest a newly opened route or a shift in connections. But it's worth remembering what that map really is. At first glance, it looks like geology. Dots marking volcanoes, lines or arrows indicating the spread of material from each source. Yet beneath the chemical signatures and the topography, what we're really seeing is a record of human decisions. Every obsidian flake outside its source zone is the outcome of someone's choice to walk in one direction rather than another, to invest effort in carrying heavy stone instead of something else, to maintain a relationship with neighbors who could provide access, or to seek out new partners when old pathways failed. The obsidian map of Anatolia is not just a picture of where volcanoes happen to be. It's a shadow map of ancient itineraries, of remembered paths through mountains and across plains, of favorite campsites and seasonal gathering places. It's a map drawn unconsciously by thousands of individual journeys over thousands of years. To understand how far those journeys could reach and how people began to push obsidian beyond the land itself, we have to leave the plateau and follow the glass out to sea. When you follow those journeys west, the land falls away into something very different from the Anatolian plateau. Water, channels, islands. The Ayan is not a simple coastline. It's a jigsaw of peninsulas and scattered land masses, some only a short swim apart at low sea levels, others separated by deceptively narrow stretches of deep water. For Obsidian and for the people who moved it, this mattered. Among all those islands, one name keeps coming back in the archaeological reports: Melos. Melian obsidian is one of the clearest and strangest signals we have that Stone Age people were doing more than just walking. The island's volcanic glass has a particular chemical fingerprint, one that can be picked out reliably from other Ayan and Anatolian sources. When researchers started testing obsidian artifacts from mainland Greece, from the Cyclades, even from further afield, they kept finding the Melon signature. The puzzle is that Melos is not a coastal outcrop you can stroll to at low tide. Even when Ice Age sea levels were lower, it was still an island. To reach its obsidian, people had to cross water. That makes me Melos, and islands like it, a kind of stress test for prehistoric mobility. On the mainland, you can always argue that obsidian got around through slow, incremental exchange. One group walks a little, trades with the next, who carry it a bit farther, and so on. Over centuries, material creeps across landscapes almost by accident. Islands break that logic. At some point, a person with a particular toolkit stood on a shore, looking across a strip of sea toward land that was clearly not attached. To get there, they had to willingly leave the security of ground and commit to something else. A raft, a dugout, a skin boat. Perhaps only a bundle of logs lashed together. We don't know the exact form. What we do know is that the distribution of obsidian tells us they made that crossing. Not once, but many times. The evidence comes in layers. One layer is simple presence and pattern. Melon obsidian shows up in sites on the Greek mainland and other islands in quantities that are hard to explain by a single lost voyage or a rare curiosity. In some Neolithic settlements, the majority of obsidian tools that have been chemically tested trace back to Melos. The further those sites are from the island, the more you would expect its glass to fade out if it were just a random trickle. Instead, we often see consistent use over long periods. Another layer is context. On Melos itself, the places where obsidian was quarried and worked are not ambiguous. Archaeologists have found extensive scatterings of flakes and cores around the island's source zones, including the famous outcrops at St. Nicia. These aren't just a few chips left by a passing hunter. They are dense accumulations that imply repeated visits, possibly organized trips with the specific aim of acquiring good stone. On other islands and on the mainland, obsidian appears in domestic layers, in house floors, in trash pits, in burials. Sometimes it's mixed in with local churches and other stones. Sometimes it dominates particular tool categories. The fact that it turns up in ordinary refuse as well as in special deposits suggests that this wasn't always an exotic prestige item. In many communities, obsidian was woven into daily life. A third layer comes from the tools themselves. Melon obsidian was not only moved as shapeless chunks. At some sites close to the island, we find a full reduction sequence. Rough nodules, early-stage cores, production waste, long blades, trim tools. That looks like local knapping of raw material carried directly from the source. Further away, the picture changes. Assemblages might contain mostly blades and finished implements with very little heavy waste. That pattern points toward obsidian traveling in more processed forms. Somebody nearer to Melos, or on Melos itself, was doing the work of turning raw glass into portable packages of sharp edges before sending it on. Each of these possibilities carries a slightly different social implication. If most of the material was shipped as raw blocks or minimally tested nodules, then the cost of transport was high in weight and volume. That suggests either fairly direct trips from quarry to consumer or a small number of middle communities willing to invest in hauling heavy stone as a service. If instead much of the melon obsidian moved as pre-shaped cores or neat bundles of blades, the emphasis shifts. Now, what is being moved is not just geology, but expertise. Somewhere near the source, knappers were standardizing products, perhaps to meet expectations from downstream partners. The glass leaving the island would already embody decisions about size, form, and quality. Down the line, other communities could resharpen or modify these imports, but the basic package was defined at or near the source. The archaeological record hints that both strategies were used at different times and places. Early in the sequence, we see more evidence for raw or lightly reduced material traveling. As seafaring and exchange networks matured, the balance seems to tilt toward more finished products moving across the water. Whatever the exact mix, the key point remains. Obsidian was crossing stretches of open sea in a patterned, sustained way. What kind of boats made this possible? Here, the evidence becomes indirect and caution is essential. Wood and fiber rarely survive for tens of thousands of years in the iron environment. We do not have a Paleolithic canoe neatly preserved on a beach, but we can bracket the possibilities. People capable of knapping standardized blades, organizing quarry expeditions, and maintaining social ties over dozens or hundreds of kilometers were unlikely to be helpless in water. Experimental archaeology has shown that simple log rafts, reed bundles, or dugout canoes can handle iron crossings under the right weather conditions, especially if used seasonally and with intimate local knowledge of currents and winds. The obsidian doesn't tell us whether they favored one design over another. It does, however, tell us something about scale. The volumes of meon glass found in some Neolithic villages suggest that crossings were not one-off heroic feats. They were probably routine enough that people were confident loading not just themselves, but extra stone, perhaps along with food, water, and other goods. It's also likely that obsidian wasn't traveling alone. Once you imagine regular sea paths between Milos, neighboring islands, and the mainland, it becomes hard to limit the traffic to volcanic glass. People moving back and forth would have been carrying stories, marriage partners, shell ornaments, pigments, perhaps domesticated plants and animals. Once farming began, the same roots that carried sharp black blades could easily have carried ideas about house styles, rituals, or exchange obligations. In this way, iron-obsidian circulation becomes more than a mineral distribution map. It is an early glimpse of a maritime network. Islands like Melos, Yali, and others with accessible stone resources would have functioned as nodes. Coastal communities on the Greek mainland and western Anatolia would have been the links anchoring sea routes to river valleys and inland plains. A block of melee glass napped on a site in central Greece may have traveled by a chain of short hops. Melos to another Cycladic island, island to mainland port, port to interior village, village to upland pasture. When geochemical sourcing shows me obsidian turning up deep inland, far from any shore, it suggests that these coastal nodes were not endpoints. They were interfaces where sea paths met land paths. Obsidian crossed from boat to basket, from sailor to shepherd, and then continued on foot. Looking at the iron this way, the water is no longer a barrier at the edge of an Anatolian world. It's another kind of road. Those sea roads, tested first by small crews edging from bay to bay, would later become the highways of Bronze Age traders and classical sailors. But their foundations, as far as obsidian can tell us, were laid much earlier by people for whom volcanic glass was a compelling reason to push off from shore and trust themselves and their networks to the sea. If the Ayan shows us how people learn to treat water as a kind of road, the Levant shows us what happens when land itself funnels movement. Stretch a mental map from southern Turkey down through Syria, Lebanon, Israel, Palestine, and Jordan. Between the Mediterranean on one side and the harsher deserts on the other, there's a relatively narrow strip of land where rainfall is a bit more generous. Rivers and springs are more frequent and habitats string together into a chain instead of breaking into isolated pockets. Archaeologists often describe this as a corridor, not a straight, well-paved highway, but a set of overlapping routes that all tend to run north-south, threading through coastal plains, upland ridges, and inland valleys. For tens of thousands of years, anyone moving between Anatolia and northeastern Africa, or between the highlands of inland Asia and the Mediterranean coast, found themselves channeled through some part of this belt. Obsidian makes this visible in a way few other materials can. There are no obsidian-producing volcanoes in the Levant itself. The closest major sources sit to the north and northeast, in central and eastern Anatolia, and further out toward the Caucasus. Yet at sites scattered along this corridor from the Upper Paleolithic into the Neolithic, archaeologists find obsidian blades, flakes, and cores. When those pieces are tested, many of them trace back to those distant northern sources. In the technical language, these artifacts are non-local. That simply means the rock they're made of does not exist in the geology around the site where they were found. But in human terms, non-local is not just a label. It's a measure of how many days of walking lie between source and destination. If a chunk of obsidian in a Levantine camp comes from central Anatolia, we're talking about hundreds of kilometers as the crow flies, and often more along real paths that detour around mountains and track water sources. Even for highly mobile hunter-gatherers, that represents a serious journey. This raises a basic question. Whose journey are we seeing? One possibility is direct procurement. A group based somewhere in the northern Levant, perhaps near today's Syria or Lebanon, could have organized occasional expeditions northward toward the obsidian-bearing zones of Anatolia. People might follow familiar river valleys and passes, visit known quarries, pick up raw blocks or early-stage cores, and then turn around and bring them home. In that scenario, each piece of non-local stone still reflects movement, but most of that movement is done by the very people who eventually use it. Another possibility is almost the opposite. The obsidian in a southern Levantine site may never have been handled by anyone who had seen the volcano it came from. Instead, it might have trickled down the corridor through multiple exchanges, traded from one group to the next, sometimes as raw nodules, sometimes as partially worked cores, sometimes as finished blades passed along with other gifts. This is the down-the-line model. No single group walks the full distance between Anatolia and, say, the northern Sinai. Yet over time, obsidian still covers that ground, moving in small steps as people meet, camp together, intermarry, or share feasts. Can the material itself tell these stories apart? Sometimes it can offer hints, though rarely a neat answer. At sites relatively close to inferred sources, archaeologists sometimes find evidence of the whole napping sequence. There are big, heavy chunks of raw glass roughing out waste, and the finer flakes left by the final stages of shaping tools. That full spectrum suggests that someone nearby had direct access to large nodules. They weren't just receiving a few pre-packaged blades, they were doing much of the work themselves. Further down the corridor, the assemblage can look very different. Levantine sites, several hundred kilometers from any known volcano, may contain mostly small flakes, retouched tools, and perhaps a few exhausted cores. But little of the bulky early-stage waste you'd expect if raw blocks were arriving regularly. That kind of pattern fits better with obsidian reaching these places already reduced. Perhaps as well-formed blade cores, or as bundles of long blades ready to be turned into specific tools. Someone else further north has already done the heavy lifting. On top of these technological clues, there's the simple matter of quantity. In some Levantine camps and villages, obsidian is a rare ingredient, a few slivers among thousands of local flint artifacts. In others, especially later Neolithic settlements, non-local glass can form a substantial minority of the chipped stone toolkit. The more abundant and systematic the use, the harder it is to explain it as the result of a single heroic trek or a one-off caravan. Instead, it starts to look like a regular flow, supported either by repeated direct journeys by established down-the-line networks or by some mix of both. This is where the Levant's role as a corridor becomes important. People in this belt were not standing still. Even without trade in mind, many groups had seasonal rounds. Herds moved between lowland winter ranges and upland summer pastures. Edible plants ripened at different times in different zones. Bands might spend part of the year near the coast, part in interior valleys, part on the edge of steppe or desert. Along these circuits, there were places that drew people together, Some sites along the Levantine corridor show unusually dense occupation layers and repeated use over long spans of time. Others are rich in hearts, animal bones, and artifacts, yet show signs of only short-term episodic visits. Archaeologists interpret some of these as aggregation sites, locations where multiple groups who might spend much of the year apart came together seasonally. In such gatherings, obsidian could change hands without anyone imagining themselves as traders. You can picture the scene in very simple terms. 2 or 3 bands arrive at a familiar spring or rock shelter within a few days of each other. They share hunting grounds, arrange marriages, settle disputes, exchange news about distant relatives and strange weather. Around the edges of those conversations, material things move too. Someone who has just come down from the north might arrive with a few fresh obsidian cores, picked up along their own seasonal path, or acquired from another group they met months earlier. Someone from further south might have access to shells from the Red Sea, pigments from particular outcrops, or fine quality flint. Bits and pieces change hands as gifts, as part of marriage arrangements, as tokens of obligation, or simply as practical swaps. No one has to carry obsidian across the full length of the corridor in a single lifetime. But over generations and many such meetings, the material slowly extends its range. From an archaeological perspective, teasing apart these scenarios is difficult. We can see that obsidian is present, and we can determine where it came from geochemically. We can examine how it was worked locally, and whether that changes with distance from the source. We can map where it's more common and where it's rare. What we cannot see directly are the specific social occasions that moved it. The handshake that sealed a marriage alliance. The quiet loan repaid years later. The visit of a small party of strangers following a rumor of good stone. Still, the pattern of finds along the Levantine corridor suggests that by the time farming villages appeared, there were already established habits of movement and connection along these north-south routes. Even in earlier purely foraging context, the presence of non-local obsidian in modest but persistent quantities points toward networks that reached beyond a single valley or tribe. The evidence doesn't force us into a simple choice between highly mobile groups fetching their own stone and sedentary groups trading through long chains. Both mobility and exchange were almost certainly involved in shifting proportions as climates, populations, and technologies changed. What obsidian does is anchor those ideas in something measurable. A flint tool made from local chalky nodules tells us that people knew their immediate landscape. An obsidian blade whose chemistry points to a volcano weeks of walking away tells us they were also linked directly or indirectly into a much larger geography. In the Levant, that larger geography ran along the grain of the land, funneled by coasts and deserts into a set of corridors. Through those corridors moved people, animals, stories, and sharp black glass, joining Anatolian highlands, Levantine valleys, and eventually the world beyond. To understand how deep these connections go, we need to step back in time, before fields, before pottery, before permanent houses. Imagine the same landscapes we've just been talking about, but stripped of villages and fields. No rectangular mud brick houses, no storage bins, no domesticated wheat waving in the wind. Instead, there are shifting camps, circles of footprints, clusters of hearths, thin layers of ash and bone left by people who might stay a few weeks or a season and then move on. Climates were not stable back then. Over the last 100,000 years and longer, ice ages advanced and retreated. Forests crept into steppe, steppe turned back into desert, rivers shifted course, lakes swelled, shrank, and disappeared. The world of Paleolithic hunter-gatherers was a moving target. In that world, mobility wasn't a lifestyle choice. It was how you stayed alive. Groups followed migrating herds, tracked the ripening of wild plants across altitude and latitude, and learned to read landscapes that were constantly being rearranged by climate swings. A territory for them was not a neat circle around the village. It was more like a web of favored valleys, water sources, hunting grounds, and seasonal camps spread over hundreds or even thousands of square kilometers into this shifting web. Obsidian appears quietly and early. Long before the first farmers in Anatolia or the Levant, there are Upper Paleolithic sites where a few obsidian flakes turn up among overwhelmingly local stone. In central Anatolia, in parts of the Zagros in the Caucasus region, hunter-gatherer camps dating back tens of thousands of years contain slivers of volcanic glass whose chemical fingerprints match sources tens or even hundreds of kilometers away. In some cases, the source is visible on the horizon. A group might camp within sight of a dark volcanic dome and walk a day or two to pick up nodules along old lava flows. That kind of local movement fits well with what we know of forager behavior. But again and again, there are examples that stretch beyond that simple picture. At sites where the nearest known obsidian source lies far outside what most models would predict for an individual band's day-to-day foraging radius, a small number of pieces still appear. Sometimes we're talking about distances of 200, 300, even 400 kilometers in straight-line terms, through landscapes that would have been rugged even in good climate phases. That doesn't mean a single person walked all that way with one prized flake in their pocket. It might mean that over generations, people's movements and exchanges stitch together those distances. Still, the existence of those pieces raises awkward questions for the old textbook image of Paleolithic life. Tiny, self-contained bands, each largely isolated within its own little territory, only rarely meeting strangers. If that image were accurate in a strict sense, we would expect most stone to be local almost all the time, with only the very occasional exotic item carried home from a youthful adventure. Instead, what we see in several regions is a pattern of rare but persistent, non-local obsidian turning up again and again over long spans of time. This is where it helps to think not just in terms of how far could one group walk, but how far their seasonal rounds might overlap with the rounds of their neighbors. A foraging band might have a core area they know best, with favorite springs, hunting blinds, and plant-gathering spots. Around that, there are fringe zones they visit only in some years, when rainfall is good or when herds shift their routes. Beyond those fringes lie other groups' core areas, with their own loops and rhythms. Where these loops overlap, people meet. Those meetings might be cautious first, then habitual. A neutral valley where herds tend to pass in autumn. A lake shore that holds water even in dry years. A particular rock shelter that's big enough to host more than one band at a time. In such places, information can move faster than genetics. Stories about distant valleys, about unusual stones, about a mountain of black glass that breaks into edges sharper than anything else. Alongside stories, objects can move too. One group's periphery might be another group's home. If the northern neighbors pass near an obsidian-bearing volcano on their seasonal round, they might bring a few chunks with them when they head south. They may chip off some blades for their own use, then pass one or two on when they meet people who have good access to something else. High-quality flint, red ochre, access to a reliable wetland in drought years. Over generations, a network of such overlapping movements could allow obsidian to drift far beyond any one group's usual range without requiring anyone to trade in a formal sense or imagine themselves as part of a long-distance system. This is one way to think about those rare exotic pieces, not as signs of caravans or specialists, but as the archaeological shadows of long, slow, ordinary movement. At the same time, the obsidian record doesn't stop at isolated curiosities. In some late Upper Paleolithic and Epipaleolithic contexts, especially closer to major source zones in Anatolia and the Caucasus, obsidian is present in more than token amounts. You see cores, multiple flakes, sometimes tools that show deliberate repeated use. The quantities are still small compared to what appears later in Neolithic villages, but they're large enough to hint at something more than a single lucky find. Here, the distinction between exotic piece and sustained flow becomes important. An exotic piece is a one-off, a handful of flakes in a layer representing centuries of occupation, perhaps never replaced when they break or are lost. A sustained flow shows up as obsidian reappearing in layer after layer over long spans of time and in enough quantity that people seem to rely on it for particular tool types. In some Paleolithic sequences near major obsidian provinces, that second pattern is beginning to appear even before farming. It suggests that certain forager groups had integrated access to volcanic glass into their lifeways, whether through regular visits to source zones or through dependable ties to people who lived closer to those zones. How to interpret this is still debated. One school of thought emphasizes mobility. In this view, Paleolithic people were moving over astonishing distances as part of their normal annual or multi-year cycles. Long-lived bands might have extremely wide territories, shifting camp rarely but covering hundreds of kilometers over a year or two. In that case, obsidian doesn't require trade at all. It's simply collected when the group happens to pass by. Another perspective stresses social ties. It accepts that hunter-gatherers were mobile, but suggests that the key to long-distance obsidian is not gigantic territories, but chains of relationships, kin marriages that link far-flung groups, ritual gatherings that draw people to specific places at specific times, and enduring obligations that travel with gifts. From this angle, obsidian is less a testimony to how far feet could walk, and more to how far trust and obligation could reach. It's also possible that both explanations are partly right, and that their importance shifted with climate and time. During stable phases with predictable resources, territories might contract, and social ties carry more of the burden of connection. During unstable boom and bust periods, groups might push outwards, covering greater distances and encountering new neighbors and new stones. The Paleolithic record, especially for obsidian, doesn't allow a neat verdict. We can see that non-local glass is present, sometimes from surprisingly distant sources. We can see that in some regions, it's not just a freak occurrence, but reappears across multiple layers and sites. We can sometimes reconstruct the local napping sequence and notice when obsidian is being used in a planned systematic way. What we cannot yet do is read off a precise social model from these shards. Were the people who carried them seasoned travelers who personally walked from steppe to forest and back? Or were they embedded in networks where friends of friends passed along useful stone, the way people today circulate news or stories? The safest answer is that the Paleolithic obsidian record before farming is already telling us two things at once. First, hunter-gatherer worlds were larger than a single valley. Whether through movement, marriage, or seasonal gatherings, people were routinely connected to landscapes and resources beyond their immediate horizon. Second, those connections were not casual. Even when obsidian is rare, its consistent appearance over long periods suggests organized habits of movement and relationship, not random accidents. By the time Neolithic villages appear, with their storage pits and walls and more abundant obsidian tools, they're inheriting a geography of connection that had been slowly woven through the Paleolithic. Farming accelerates and reshapes those flows, but it doesn't create them from nothing. The black glass had already been moving quietly across a hunter-gatherer world of shifting ice, changing rains, and overlapping paths. When farming enters the story, the tempo changes, not overnight and not everywhere at the same time, but gradually, unevenly, across the same landscapes where obsidian had already been drifting for millennia. Picture one of those favored valleys where foragers once camped seasonally. There's still a river, still wild grasses, still herds passing through. But now, on a low terrace above the floodplain, there is something new. A cluster of houses that doesn't pick up and leave when the seasons turn. Neolithic villages anchor people in place. Fields and herds tie families to particular patches of land. Storage pits and granaries make it possible to survive bad years without having to abandon everything and gamble on a new territory. But settled doesn't mean motionless. Instead of whole bands ranging over hundreds of kilometers, you have a different kind of movement. Shorter but more frequent trips. Paths beaten between village and field, village and pasture, village and nearby hills where good stone can still be found. People are rooted, but their days are full of small journeys. To check flocks, to visit in-laws in the next hamlet, to attend a seasonal ceremony at a place that's been important since long before anyone sowed grain. In this new rhythm, obsidian begins to move differently too. Archaeologically, the shift is stark. In many early farming communities across central Anatolia, the Ayan Fringe, and the northern Levant, obsidian no longer appears as a rare curiosity. It shows up by the kilogram: cores, blades, chips from toolmaking that carpet house floors and courtyard surfaces. The same chemical fingerprinting techniques that linked isolated Paleolithic flakes to far-off volcanoes now show entire Neolithic villages drawing heavily on particular sources. In some cases, the source is relatively nearby, within 50 or 100 kilometers. In others, the connection stretches several hundred kilometers, sometimes crossing mountain chains or seas. What changed was not only where people lived, but how many people there were and how they needed to work. Farming supports larger, denser populations. A valley that might once have hosted a handful of mobile bands can now sustain several hundred, even a few thousand people distributed among multiple villages. More people means more hands planting and harvesting. But it also means more mouths to feed, more tools to make, more repairs to carry out every single day. Stone tools in a farming village are not occasional implements. They become part of an everyday toolkit. Sickles made with fine obsidian blades used to harvest grain. Long regular blades are snapped into segments and hafted into wooden handles. Scrapers process hides from domestic animals. Drills and points pierce bone, wood, and early pottery. When you scale that up from a single household to an entire village, demand for sharp, reliable cutting edges rises dramatically. At the same time, life in houses and fields encourages specialization. In a small foraging band, almost everyone learns basic napping skills. In a compact village with dozens or hundreds of people, it becomes efficient for some individuals to focus on particular tasks. In many Neolithic sites, you can see this emerging division of labor in the stone itself. Instead of a jumble of ad hoc flakes, you start to see standardized blades. Long, narrow pieces of obsidian produced by carefully preparing a core and then striking off series of parallel blades with practiced, repeatable blows. The cores themselves show characteristic shaping, a technical signature of experienced knappers who know exactly what they're doing. These aren't people casually banging rocks together in a spare moment. They are craftspeople. Sometimes their activity clusters in specific parts of a settlement. Certain houses or courtyards accumulate thick layers of napping debris, core fragments, rejected blades, piles of tiny chips. Other houses of finished tools, but very little production waste. One way to read this pattern is as household production. Each household takes in raw nodules or pre-shaped cores. Someone within the family turns them into tools, and the waste simply happens to concentrate more in some spots than others. Another way increasingly considered in the literature is to see signs of more organized production. If one house consistently has large numbers of cores, failed attempts, and half-finished blanks, while many others have almost none of that, but do have finished blade inserts, it suggests a different model. Perhaps a few specialists or specialist households were producing blades not only for themselves, but for many others. In that case, obsidian is no longer moving simply as raw stone or as occasional finished items carried by individuals. It is being drawn into a village-level provisioning system. Some researchers talk about two poles on a spectrum. At one pole, household-level acquisition. Each family arranges its own access to obsidian. That might mean someone from the household goes on periodic trips to a nearby source or to a regional gathering where obsidian is available. They bring back a modest amount, nap most of it at home, and use or pass along finished tools as needed. At the other pole, community-level provisioning. A smaller number of people, perhaps with better connections to source areas or neighboring groups, organize the flow of raw material in bulk. They may travel farther or negotiate access through specific kind ties. Once obsidian arrives in the village, dedicated knappers convert it into standardized products that can be distributed widely. The archaeological record doesn't always let us choose definitively between these models. Often what we see in Neolithic Anatolia and the Levant looks like a mixture. There are houses with their own modest knapping debris, suggesting local household skills. And there are concentrations of much more intensive production, hinting at people who are known, perhaps even sought out, for their ability to turn black glass into precise, interchangeable pieces. Whatever the internal arrangements, the effect on the wider landscape is clear. Neolithic villages act as nodes that intensify and stabilize obsidian flows. A mobile forager group might visit a volcanic source only every few years. A network of farming villages, by contrast, can maintain almost continuous contact with source zones and with each other. News of a good quarry, a safer path through the mountains, or a new way of shaping blades can ripple through this network with a speed that would have been hard to achieve in Paleolithic times. Yet, we have to be careful with our language here. When we see obsidian from one region turning up in many villages hundreds of kilometers away, it is tempting to talk about trade routes and markets as if there were permanent shops and dedicated merchants operating in ways familiar from much later periods. There may have been some individuals who made a habit of moving goods between communities, but trade in the Neolithic likely covered a wide range of practices that don't map neatly onto modern economic categories. Obsidian might move as gifts given at marriages, as part of alliances between lineages. A visitor might bring a bag of blades as a gesture of goodwill, or as compensation in dispute settlement. People might exchange obsidian for livestock, grain, pigments, or ritual items, not in a fixed price system, but through negotiated context-dependent arrangements. There could be delayed reciprocity. You host a visiting group today, feed them from your stored grain, and in a later season, they arrive with obsidian from a distant cone, or with access to grazing land when your own fields are parched. All of these are forms of exchange. When archaeologists map obsidian distributions in Neolithic Anatolia and the Near East, they are not necessarily revealing markets in the modern sense. They're seeing the material traces of social relationships, obligations, favors, ritual ties, and shared histories that happen to involve the movement of volcanic glass. Settled villages then do two things at once. They tether people to specific places strongly enough that dense, enduring communities can form. And they create strong, predictable demands for certain materials like obsidian, which in turn encourage more organized systems for moving those materials around. The result is an acceleration of exchange. The same black glass that once drifted slowly along the overlapping paths of foraging bands is now flowing more regularly, in larger volumes along routes structured not just by geography and climate, but by the needs and social arrangements of village life. In the next step of the story, this acceleration will become even more visible as we zoom in on the workshops themselves, the hands that struck those blades, and the hidden specialists whose skills quietly shaped Stone Age economies. If you could sit quietly in a Neolithic village and just watch the ground for a while, the workshops would eventually give themselves away. Not because of signs or fences or anything we'd recognize as a factory, but because of what archaeologists call the debris of production. When someone turns a raw obsidian block into a neat stack of blades, most of what they create is not tools, it's waste. Archaeologists have a word for this: debitage. All the little flakes and chips that fly off when you strike a core. The tiny angular pieces that collect where someone sat and worked for hours. To a casual eye, it's just gravel. To a trained one, it's a fingerprint of activity. In a light-use area, you might find a few scattered flakes, a broken tool or two, the occasional small core somebody worked on for a short time. In a production area, you get something very different. Dense carpets of tiny chips, stacked lenses of waste built up over multiple episodes, sometimes packed so thick they form actual layers in the archaeological record. Mixed into that carpet are other clues. Cores, for instance. A core is the chunk of stone from which flakes or blades are struck. In simple flaking, a core might be any rock you bat around until it looks too messy to use. In more advanced traditions, the core itself is carefully prepared. Surfaces are smoothed, striking platforms are shaped, angles are adjusted so that when the nappa hits, the stone responds in a predictable way. When archaeologists talk about platform preparation, this is what they mean. trimming and shaping the spot where the blow will fall. Also, the force travels in the right direction at the right depth. The tiny scars left behind on those platforms tell us someone knew exactly how to coax glass into behaving almost like metal. Then there are the rejects. Not every attempt works. Blades snap, flakes plunge too deep into the core. A miss it sends a fracture skittering across the surface, ruining hours of careful preparation. Those failures accumulate. Thick piles of snapped blades, misruck cores, half-finished blanks abandoned when a fracture ran the wrong way. Taken together, dense debit, heavily worked cores with systematic platform preparation, and large reject piles. These patterns are what archaeologists look for when they say, "This isn't casual, this is a workshop." It's in these contexts that blade technologies really stand out. A blade, in this technical sense, is not just any long, sharp piece. It has a particular geometry, longer than it is wide, with roughly parallel edges and a fairly standardized cross-section. Producing a sequence of blades like this from a single core requires a long chain of deliberate steps. You have to select the right raw material. Obsidian, free of internal flaws big enough to sustain multiple removals. You shape the core into an elongated form, often with a carefully faceted platform at one end. You stabilize the core in your hand or against a support. Then you strike again and again, adjusting force and angle so that each blow removes a long, thin sliver without ruining the core for the next one. This is not something most people can do well the first time they try. Ethnographic studies of traditional nappers and experimental archaeology, where modern practitioners try to reproduce ancient techniques, both suggest a long learning curve. There are subtleties you can't easily see, only feel. The slight change in resistance as the core heats in your hand, the way a platform rings when it's at the right angle, the almost instinctive adjustments to force when you sense an incipient crack. To get to the point where you can reliably turn out dozens of nearly identical blades from a single core, you probably need years of practice. That implies something more than casual imitation. It suggests structured learning. Children watching older relatives, then trying on cheaper stone, then being trusted with prized obsidian. A form of apprenticeship, even if nobody would have used that word. Where that learning took place is harder to pin down. One model imagined specialists who moved between communities. Perhaps there were individuals renowned for their skill, invited to visit neighboring villages for seasonal work, shaping cores, teaching techniques, maybe staying through the harvest or a ritual season, then moving on with gifts and raw material in return. If that happened, we might expect to see very similar blade traditions spreading widely, not just in the final products, but in the details of how cores were prepared and how platforms were shaped. A kind of stylistic signature carried from place to place in one person's hands. Another model keeps the specialists more rooted. In this version, communities travel to the workshops rather than the other way around. Certain locations near a good quarry, or perhaps a long-occupied village with particularly skilled lineages, become seasonal hubs. People arrive with baskets of raw nodules or partly prepared cores, camp for a while, and leave with finished or nearly finished blades. Archaeologically, such a place might show massive quantities of production debris and very little domestic architecture, or an ordinary settlement with unusually intense napping in particular zones. There is also a quieter possibility that most villages had their own in-house specialists, people who rarely traveled far, but whose reputations extended through kin networks. A marriage might bring a skilled napper into a new community. A child sent to spend a season with distant relatives might return with both stories and a new way of working stone. These scenarios are not mutually exclusive in different regions or even within the same valley at different times. The balance between traveling specialists, visiting customers, and local craft households could have shifted. What we can see with more confidence is the spread of standardized forms. When archaeologists compare obsidian tools from many sites across Anatolia and the Near East, they often find striking similarities: bladelets of similar dimensions, sickle inserts with the same retouch patterns, cores worked down in comparable sequences. Those similarities don't necessarily mean that one central workshop supplied everyone. They can also arise if knowledge itself is what travels. A trader might carry a handful of blades to a distant village, not just as objects to be used, but as models to be copied. Someone studying those blades can begin to reverse engineer the method. A visiting cousin might learn a new core preparation technique and bring it home, adapting it to local habits. In that sense, standardized obsidian forms can move through networks in two ways at once, as finished artifacts and as embodied know-how. A single remarkable blade admired around a hearth might inspire others to try to match it. Over time, successful experiments converge on similar solutions, especially when the mechanical properties of obsidian push knappers toward particular shapes and angles that work best. So, when we stand back and look at the archaeological map, dense workshop debris in some sites, lighter household napping in others, shared technological signatures over broad areas, we're left with several overlapping pictures rather than one simple story. There may have been full-time or near full-time specialists whose days were dominated by the rhythm of percussion on glass. There may also have been part-time experts, farmers who did most of their napping in the off-sea, but whose skill quietly underpinned village economies. And there were almost certainly many people with basic competence, capable of routine repairs and simple flakes without ever approaching the virtuosity of core blade masters. What the stone record can't yet tell us with certainty is how these roles were organized socially. Were skilled nappers high-status figures courted by many households? Or were they taken for granted, their work so woven into everyday life that it rarely rose to the level of ritual or prestige? Did some individuals roam as itinerant craft workers, carrying both blades and stories between far-flung communities? Or were most workshops anchored, drawing people and raw material toward them like quiet gravitational wells? The evidence allows several of these models to coexist. What it does show unmistakably is that obsidian technology in the Neolithic was not just about having sharp edges. It was about maintaining chains of skill, patterns of learning, and networks of exchange that turned volcanic glass into a shared, standardized resource. Those hidden specialists, whether they traveled widely or barely left their courtyards, helped knit together a world where stone, knowledge, and social ties moved along the same paths. In the next step, we can zoom out again and watch how those paths carried obsidian far beyond the immediate reach of any single workshop through a process archaeologists call down-the-line exchange. Down the line. Exchange sounds technical, but the basic idea is simple enough to follow half asleep. Imagine you live in a village close to an obsidian source. The glass is not magical to you. It's useful, sometimes beautiful, but it's also familiar. You can walk to the quarry in a day. You know which outcrops are good and which ones shatter. You may not treat it like gold. A few valleys away, things look different. There, obsidian doesn't just lie around. People might see it once a year or once in a lifetime. A single glossy blade, black with that faint green or purple sheen, might be the sharpest object anyone in the community has ever handled. Now, stretch this contrast across many communities, each one a little farther from the source. That's where down-the-line exchange comes in. Instead of one heroic trader marching hundreds of kilometers with a sack of obsidian on their back, you picture a chain of short, ordinary movements. A village near the source has more obsidian than it strictly needs, so some of it leaves as gifts or as part of marriage exchanges or carried by visitors heading home. The next village keeps most of what it gets, but passes on a little further, and so on. At each step, the amount shrinks. Pieces are used, reworked, broken, hoarded. Only a fraction keeps traveling. If you map this archaeologically, you get what researchers call a distance decay pattern. Near the quarry, obsidian is everywhere. Big cores, thick flakes, heavy blades, waste scattered across many households. A little farther out, you still find plenty, but the pieces tend to be smaller, more carefully worked, more often reused. Move farther again, and obsidian becomes rare. A few tiny tools in a whole excavation, sometimes only slivers in special contexts. The probability of finding obsidian and the average size of the pieces both tend to decrease as you move away from the geological source. It's a quiet statistical gradient, not a dramatic frontier, but it's exactly what you'd expect if materials passed from hand to hand through many small local transactions instead of being hauled in bulk by specialists. Those transactions didn't have to look like markets with prices and bargaining. In Stone Age societies, much of what we'd now call trade was probably woven into gifting and reciprocity. You visit relatives in a neighboring valley. You bring food, news, maybe a few finished blades or a prepared core, not because you've calculated their value, but because relationships are maintained through giving. Your hosts respond with hospitality, shelter, perhaps access to a spring or pasture. They may give you something in return: a rare pigment from a nearby cliff, a shell from a distant shore, a woven item that takes days to make. Nobody writes anything down, nobody calls it a contract, but everyone remembers. Over time, expectations form. Families known for their access to obsidian might be expected to show up with stone periodically. Families with good grazing or salt or fine pottery show their own generosity in turn. This is where obsidian can travel surprisingly far without anyone setting out to be a long-distance trader. Each participant in the chain is acting within a short familiar radius, dealing mostly with people they already know, or at least know of. Alliances work the same way. A marriage across communities is not only about two individuals. It creates a durable link between entire groups. When a daughter marries out or a son marries in, gifts move with them. Dowries, bride wealth, ceremonial exchanges. These can easily include the high-status, sharp, eye-catching material everyone has noticed: obsidian. Once that connection exists, it can carry more than people. It can carry a steady trickle of stone, information, and obligations. In times of need, a bad harvest, a conflict, a sickness, those same ties might be activated for help. From the outside, centuries later, we don't see the arguments or the laughter or the awkward visits. We see the pattern. Obsidian from source A turning up in small, well-traveled quantities in regions B, C, and D, each a little farther and thinner than the last. For this kind of system to work, there has to be something acting like infrastructure. Even if no roads have been cut and no government is enforcing agreements, that something is trust. Trust and reputation are the invisible scaffolding of down-the-line exchange. If you give away a prize blade now, you have to believe that generosity will somehow return to you or your descendants. Not immediately, not as a simple repayment, but as part of a cycle of favors and recognition. Groups that reliably share in times of plenty, that host visitors without cheating them, that treat affines and guests with respect, slowly become known as good partners. Stories travel with the stone: who was fair, who was stingy, who broke an agreement. In a world without writing, reputation is memory turned into social capital. It shapes who receives gifts, who gets invited to gatherings, who is warned about danger or told about a new source of useful stone. It also shapes who gets cut off. And this is where we encounter social boundaries. When archaeologists map obsidian sources and their distributions, they sometimes notice something odd. The distance decay pattern doesn't just fade smoothly into nothing. Instead, it may drop off sharply at a certain line on the landscape. On one side of a river or mountain range, obsidian from a particular volcano is common. Just beyond, in territory that is physically accessible, it's almost absent. Even though people clearly lived there and used other stones, this suggests that exchange networks did not cover the map evenly. They were structured by cultural frontiers, zones where language, identity, ritual, or history made cooperation difficult. Perhaps two neighboring groups had old hostilities. Perhaps myths warned against crossing a particular ridge. Maybe marriage rules, ritual obligations, or simple prejudice limited who could marry whom, and therefore who could reliably trade. From far away, we just see the outcome: a network that stops short of its geographical potential. Obsidian is a wonderful tracer of such connections, but it is also mute about motives. From the chemistry of the glass, we can say with reasonable confidence that the piece found here came from a volcano there. By looking at abundance and artifact types, we can sketch the rough shape of a network, guess at whether exchange was frequent or rare, bulk or trickle. What we cannot see directly is why people moved it. Was a particular blade given as part of a courtship ritual or as a peace offering after a fight? Did the village stockpile cause as security against future scarcity, or as a way of signaling prestige to neighbors? Was a distant piece of obsidian carried for its sharpness, its shine, its symbolic meaning, or simply because it was what a traveler happened to have in their pack? The stone alone does not answer these questions. We exchange and the social glue that supports it leave a clear trace in distributions and distance patterns, but they do not write out their own story. To approach that, archaeologists have to combine the obsidian map with settlement patterns, burial customs, animal bones, plant remains, and comparisons with more recent societies. When all of that is brought together, a picture begins to emerge. A world where volcanic glass moved not just along paths of utility, but along paths of relationship. Where every sharp black flake in a distant village is a tiny fossil of trust, memory, and boundary. In the next step, we can set those invisible networks against the actual landscape, the mountains, rivers, and passes that guided feet and choices, and see how people in the Stone Age turned difficult terrain into the routes along which obsidian and obligations flowed. If you look at a modern map of Western Anatolia or the Northern Levant, it's easy to draw straight lines between obsidian sources and find spots. Your eye jumps from volcano to village, village to coast, coast to island. It's tempting to say, there's the route. But nobody in the Paleolithic walked on maps. They walked in bodies with sore feet and hungry stomachs across actual ground, ridges, ravines, muddy floodplains, thorny scrub, snow on passes, summer heat on bare rock. To understand the path obsidian actually took, we have to translate those green lines into live geography. Start with the mountains. Anatolia is not a flat stage with a few scenic hills added. It's a tangle of folded ranges and high plateaus. Between the Black Sea coast and the Central Plateau, between the Ayan and the interior, there are belts of rock that can feel endless when you're moving on foot. Yet even the roughest mountains are rarely a uniform wall. There are passes, lower saddles between peaks, broad upland basins, long sloping valleys that gently climb instead of lunging straight up. In modern GIS software, archaeologists call these least cost paths, not the shortest line, but the one that demands the least effort, the fewest, the gentlest slopes, the easiest river crossings. When you run a lease model between, say, an obsidian source in central Cappadocia and a Neolithic village on the Ayan coast, the simulated path winds through a series of these natural corridors. It skirts the steepest ridges, follows high valleys, drops into major river systems whenever it can. That model is not a GPS track from the Stone Age. It's a hypothesis about what would have been reasonable. And yet, when you lay the archaeological data over it, the actual distribution of chemically sourced obsidian, something interesting happens. The densest clusters of finds often sit along those modeled corridors or just beside them, at spots that make intuitive sense, where two rivers meet, where a mountain pass opens onto a plain, where a plateau route finally reaches a lake core. Rivers are the second key. If mountains are the walls and thresholds of this landscape, rivers are its living roads. In western and central Anatolia, long river valleys, the Gedis, the Buke-Mandaras, the Sakarya, and farther east, the Euphrates and its tributaries, carve broad bands of relatively easy terrain. Floodplains offer flat walking and predictable water. Nearby terraces provide slightly raised dry ground for camps and later for villages. In the Obsidian record, these valleys light up. Pieces from central Anatolian sources occur not randomly, but in strings along these major drainage systems, sites near river confluences where one valley meets another, often show higher counts or a mix of obsidian types, hinting that they were natural crossroads where people from different directions converged. Coastlines offer a different kind of corridor along the Ayan, a narrow coastal strip broken by headlands and small bays. Ties Anatolia to the islands and beyond them to mainland Greece. In some periods, sea levels were lower than today. Shelves that are now underwater would have been exposed as low, rolling coastal plains. Islands would have been closer, some connected, others reachable by shorter crossings. A lease path model that ignores the sea will snake inland around the mountains. One that allows simple boats, short island hopping stages, and seasonal use of calm weather days produces a different set of plausible routes. Hugging coasts using estuaries as entry points, linking obsidian-rich interiors to faraway shores. The distribution patterns don't pick one model and crown it the winner. Instead, they suggest that people used both strategies at different times. Some obsidian flows clearly follow inland river axes. Other flows appear in coastal Neolithic sites in ways that make more sense if at least part of the journey was by water, even if only modest local crossings. Beyond mountains, rivers, and coasts, there is also the edge of the steppe. North of the Central Plateau, south of the Black Sea Mountains, and in parts of northern Syria and Mesopotamia, you get open rolling country that is neither dense forest nor bare desert. In some climatic phases, this steppe margin would have been rich grazing ground full of game and seasonal plants. For mobile hunter-gatherers and early herders, these open belts function like broad, flexible corridors. You don't have a single trail, you have a zone of movement, a general direction that can bend with resources and seasons. Obsidian from eastern Anatolian sources shows up along such margins, sometimes in very low densities, like a faint echo. That pattern fits down the line exchange happening inside a mobile world where people aren't funneling through a single gorge or pass, but fanning out across a wide, semi-open band of land. Over millennia, none of these corridors stayed constant. Climate swings during the late Pleistocene and early Holocene, colder, drier phases, warmer, wetter ones, changed the ease and appeal of different routes. A pass that is barely usable under deep snow might become attractive in a milder phase. A valley that offers reliable water and forage in a wet period might turn risky in a drought, pushing groups to higher ground or toward better watered coasts. Sea level changes had similar effects. At glacial maxima, more land was exposed, coastlines further out. Some straits narrowed, others remained formidable. As ice melted, low-lying coastal plains flooded, severing former land paths, turning peninsulas into islands, and changing where boats were required. When archaeologists find obsidian from a particular source at an island site, they have to ask, was this place always an island? Or did people first reach it when it was part of a larger landmass, and only later see the sea rise around it? The answer can shift how we imagine the journey. A long trek over dry ground, or a mixed route combining walking and paddling. Climate does not only move water, it moves people. During colder, harsher episodes, groups may have clustered in refuse, well-watered valleys, sheltered coasts, spring-fed basins. These refugees become predictable meeting grounds. When conditions improve and people spread out again, those former refugees remain on the mental map as places where paths cross and old relationships can be renewed. This brings us to the meeting points. Obsidian doesn't just travel along lines, it pulls in nodes. River confluences are the most obvious. Two valleys mean two directions of origin and destination. So, settle or camp at that junction, and you see more people, hear more languages, and handle more diverse objects. Lake shores function similarly. A lake is a magnet for animals, plants, and humans. Its perimeter is a slow, circular road. Sites on those shores, even when small, sometimes show a richer mix of materials. An obsidian blade from one source, a different stone from another, shells from yet elsewhere. Each object is a trace of someone arriving, staying a while, and leaving again. Seasonal camps add another layer of structure. Even highly mobile groups often return year after year to certain spots. A good salmon run, a predictable herd crossing, a sheltered basin with edible bulbs. These recurring gatherings are perfect occasions for exchange. You don't have to plan a journey to trade. You just bring what you have surplus of to where you are going. Anyway, when archaeologists find repeated thin layers of occupation at the terrace above a river, each layer containing a small but steady trickle of non-local obsidian, it's reasonable to picture this kind of seasonal fare, modest in any one year, powerful in the long build-up of connections. Now, tie all of this back to the sourcing data. When you see obsidian from a Central Anatolian volcano appearing in side-strung along a particular river valley, fading with distance but never jumping mountains that would be hard to cross, that reinforces the idea that rivers were favored corridors. When you see a mix of obsidian types at a handful of inland nodes, perhaps a junction where material from eastern and central sources both show up, you can suspect a meeting point, a place where different routes intersected. When you notice that certain coastal sites have obsidian from far inland sources, but very little from closer alternative volcanoes, separated by more rugged terrain, that asymmetry nudges you toward a picture of people preferring easy river coast combinations over short, brutal mountain crossings. Least cost path models, climate reconstructions, sea level curves, and the fine-grained chemistry of volcanic glass all converge here, not to give us a single definitive itinerary, but to narrow the field of the plausible. They suggest that Stone Age people were not randomly wandering in any direction. They were reading the same landscape features we see today: the soft invites of valleys, the bottlenecks of passes, the steady pool of water, and weaving their social networks along those lines of least resistance. In that sense, the obsidian map is not just a record of where stone ended up. It's a faint composite trace of how countless feet over thousands of years chose their way through a complicated world, turning particular mountains, rivers, and shores into the quiet highways of the Stone Age. And once you see those highways, you can begin to ask a deeper question. What did living along them or off them do to the societies that carried this glass? If we follow those quiet highways long enough, obsidian stops looking like just a raw material and starts looking like something else. A diagnostic tool for the kind of world people were living in before cities, before writing, before anyone thought to build a palace. Because obsidian is stubbornly specific. Each piece we can chemically fingerprint tells us, in effect, I came from there and ended up here. Had enough of those points and patterns emerge that are hard to explain without invoking regular, structured interaction between groups. In other words, a worked world. You can see it in the way tool styles spread. In the early Holocene, for example, certain blade shapes and core preparation methods show up at sites hundreds of kilometers apart. All made from different local materials, but following the same basic design logic. At one village, the blades are obsidian. At another, they are clay or flint. But the proportions, the angles, the ways they were snapped and retouched match closely. It's unlikely that this is coincidence or parallel invention over and over again. More plausible is that people were seeing each other's tools, handling them, and copying the techniques. A style originates somewhere, perhaps near a rich obsidian source where specialists are experimenting with new ways to get long, thin blades out of a core. Then, through visits, marriages, shared hunts, or seasonal gatherings, the idea moves. It reaches communities that may never see the original volcano, but still carry the pattern in their heads and hands. Over time, this kind of copying builds what archaeologists sometimes call interaction spheres, broad regions where people share not just tools, but elements of ritual and daily practice. At some Neolithic sites in Anatolia and the Levant, houseplants, burial customs, and even ways of decorating walls show family resemblances across long distances. When those same sites share obsidian from overlapping sources, the two lines of evidence reinforce each other. They suggest a world where contact was not a rare once-in-a-lifetime event, but something that happened often enough to create shared expectations about how life should look. That doesn't mean these worlds were utopias of equality. exotic materials almost always raise the question of status. Did obsidian belong to everyone, or was it concentrated in the hands of a few? The answer seems to vary by time and place, and the obsidian itself gives us some clues. In many early farming villages, obsidian is surprisingly common. Flakes and blades lie on house floors in mittens around hearths. They are not tucked away only in special buildings or graves. In those contexts, it's hard to argue that obsidian was an exclusive prestige item. It was valued, people went to trouble to get it, but it may have been within reach of most households, at least in modest amounts. Even there, though, we sometimes see hints of hierarchy. A few houses might have more obsidian tools than others, or higher proportions of long, carefully made blades compared to simple flakes. Certain burials might include particularly fine obsidian pieces, while most graves have none. At some sites, very large blades or unusually glossy black pieces appear in ritual deposits rather than in everyday trash. None of this proves rigid class systems or kings. What it does suggest is that people were already using material differences to create and signal social differences, to mark certain occasions as special, certain roles as distinctive, certain individuals as noteworthy. Obsidian, because it was sharp, attractive, and traceably non-local, lent itself to that kind of symbolic work. Inequality in this world may have been shallow compared to later urban societies, but the raw materials for more complex hierarchies, control over access, control over specialized knowledge, control over eye-catching objects, were already present along these obsidian routes. The same routes also tell us something about conflict and cooperation. Moving goods over long distances is risky in any era. In a landscape without states, police, or formal treaties, every value cross contains potential allies and potential enemies. Yet the pattern of obsidian distribution, at least in many periods, looks more like a quilt than a set of hard frontiers. The same source can supply multiple regions. Different sources can overlap in a single area. There are not many clear, sharp lines where one obsidian sphere stops abruptly and another begins. This kind of overlap is easier to explain if groups were at minimum tolerating each other and often doing more than that. Exchange itself can be a form of diplomacy. If neighboring communities meet seasonally to swap obsidian for animal products, pigments, shells, or information, that meeting is also an opportunity to renew peace, settle disputes, arrange marriages, and feel out the mood of people who live beyond the next ridge. Some ethnographic parallels from hunter-gatherer and early farming societies in Africa, Australia, and the Americas show that such exchanges can be heavily ritualized. You don't just hand over a bundle of stone. You dance, feast, tell stories, perform obligations. Refusing to trade can be a declaration of hostility. Continuing to trade, even lightly, can be a way of keeping a cautious peace. We cannot see dances or feasts in the archaeological record of Anatolia in the Near East, but we do see the outcome of repeated structured exchanges, steady trickles of obsidian moving along the same approximate lines for centuries. If warfare had been constant and all-consuming between neighboring groups, it would be harder to maintain those flows across wide regions. That doesn't mean there was no violence. Arrowheads and spear points made of obsidian were not only tools, they were weapons. Some skeletal remains from the region show healed or fatal injuries from projectiles and blunt force. There must have been raids, feuds, and episodes of open conflict. The obsidian record simply suggests that alongside conflict, there was also a strong incentive to maintain corridors of cooperation, narrow channels of trust, or at least predictable behavior that allowed people to keep accessing valued materials and information. And that information is the last and perhaps most important thing obsidian hints at. Stone doesn't travel alone. A person making a journey from an obsidian-rich upland to a coastal village is not only carrying cores and blades. They're also carrying news about grazing, game movements, recent droughts or floods, births and deaths, rumors of sickness, stories of strange people far away. Marriage ties often follow exchange routes. We can sometimes see this indirectly through genetic studies, which show patterns of relatedness consistent with mates moving between communities. We can also infer it from how widely shared some cultural traits become. A woman or man who moves to a new group brings not only kin connections back home, but songs, recipes, child-rearing practices, maybe a preferred way to nap a blade or decorate a pot. Obsidian, because it is so easy to trace, gives us a skeleton for these otherwise invisible flows of information. Where we see especially dense or varied obsidian at a few sites, multiple sources represented in one place, it is reasonable to imagine those sites functioning as hubs not just of material exchange, but of story exchange. People from different valleys with different experiences of weather, game, and neighbors meeting for a few crucial days or weeks a year, listening, learning, matching their mental maps against each other. Techniques travel the same way. You might learn a new way to prepare a hunting spear because a visitor shows you a hafted obsidian point that stays in better. You might see someone grind a blade in a way your community has never tried, producing an edge that works especially well on reeds or bone. You copy it. Next season, when your group meets others further along the route, they see the same thing and copy it from you. Over generations, such chains of demonstration and imitation can transform entire regions, all riding on the back of materials like obsidian that make these meetings worthwhile in the first place. When we pull back, what obsidian shows us about pre-ET society is not a world of isolated bands, each reinventing everything on their own, nor a world already dominated by centralized powers. Instead, it points to something in between, loosely connected networks of communities bound together by repeated contact, mutual dependence, and shared styles that spread faster than people do. Inequalities were emerging, but they were still embedded in small-scale face-to-face worlds. Conflict existed, but so did strong traditions of exchange and diplomacy. Information, like stone, moved incrementally along paths of least resistance, carried in the memories and relationships of people whose lives unfolded entirely without writing, markets, or states. Cities would later formalize and accelerate many of these same processes. But the obsidian trails remind us that the deep architecture of connection, the habit of building networks out of paths, promises, and things that come from far away was already in place long before anyone built a wall or crowned a king. Before we let obsidian redraw the Stone Age map too confidently, it's worth slowing down and asking what else could be going on. Because not every piece of Farivold stone is a smoking gun for human trade. One of the most common alternative explanations is also the most prosaic. Nature moved it. Volcanoes don't just erupt obsidian as neat collectible blocks. They shatter it. Rock falls tumble it down slopes. Rivers can pick up small cobbles and carry them for some distance. Glaciers in colder regions can bulldoze blocks of stone and drop them hundreds of kilometers away as they retreat. So, when we find obsidian far from any known source, we have to ask, did people carry this? Or did ice and water do the work long before any human picked it up? In some areas, that question matters a lot. In parts of Europe and the Americas, for instance, glacial transport can scatter distinctive rocks across wide swaths of landscape. A person in the late Stone Age might simply be using what the ice had conveniently dumped at their feet. But in much of Anatolia, the Ayan and the Levant, the patterns don't look like that. We're not seeing random pebbles in river gravels. We're seeing napped blades and cores made from specific obsidian sources turning up repeatedly in cultural layers at settlements and camps. The farther you get from a source, the smaller and more intensively used the pieces tend to be. The distributions tend to follow the grain of valleys and coastal routes more than the flow of ancient ice. Natural processes can explain stray nodules in odd places. They don't easily explain hundreds or thousands of artifacts from the same volcano showing up at multiple sites in an orderly pattern. Still, we have to be careful not to flip this into its opposite and say, therefore, any non-local obsidian is definite proof of long-distance trade. Sometimes what we're really seeing is the long life of a few particular objects. Stone doesn't wear out quickly. A good obsidian core, if managed carefully, can supply blades for years. When those blades dull, they can be resharpened, reshaped, turned into smaller tools. The debris from that process can be reused again as microlathes, scrapers, or drills. Archaeologists call this curation and recycling. An obsidian knife might start its career in a village right next to the volcano, move as a gift to a cousin who lives 2 days' walk away, then be inherited, carried along when a family relocates, passed further along in marriage exchanges, and slowly reduced over decades. By the time we find the final fragments at some distant site, they might represent the last stage in a tool's long journey, not a steady flow of fresh material from the source. This matters because a small number of very traveled objects can create an illusion of wide, continuous exchange. A single curated blade carried by one person who migrates a long way is not the same thing as a regular supply line. Site formation processes add another wrinkle. Settlements are not neat static layers of what people used in year X. They are palimpsests. Houses are rebuilt, floors are resurfaced, hearths are cleaned and relaid. Later, inhabitants dig pits that disturb earlier deposits. Floods can wash material into low spots. Burrowing animals move small artifacts around. Over centuries, bits of stone from different episodes are mixed together. So when we count 10 pieces of distant obsidian from a particular site, we're often mixing generations, sometimes even millennia, into one dataset. That doesn't mean the obsidian isn't important. It just means those 10 pieces may not represent 10 separate journeys. They might represent 2 or 3 episodes spread over a very long time. On top of that, our view is skewed by what we've chosen or been able to sample. Obsidian sourcing is laboratory work. It takes time, money, and access to comparative collections from known volcanoes. Early studies focused on spectacular sites, big tells, famous caves, places with rich, deep deposits. Many smaller or less glamorous sites were either not tested at all or only a handful of artifacts were analyzed. As more projects incorporate sourcing, the picture keeps changing. Regions that once looked empty of obsidian suddenly show a few pieces when someone finally checks. Places that seem dominated by a single source sometimes reveal low-level contributions from others, hidden in the noise until we had larger sample sizes. New geological surveys occasionally identify previously unknown obsidian outcrops that explain puzzling data. In other words, the obsidian map is a work in progress. Lines we draw today between source and site may look overly simple or even wrong in a few decades. This is why archaeologists get uneasy when people talk about the obsidian trade route, as if there was a single continuous highway running from a volcano to the sea. Long-distance movement doesn't automatically mean a single organized chain. A piece of stone can travel 500 kilometers without any individual person walking more than 50. It can move stepwise. One group takes it to their seasonal meeting place, trades it onward. The next group carries it further in the course of their own yearly round, and so on. On the ground, this looks less like a caravan road and more like a series of overlapping circles. Each community operates mostly within its own familiar radius, but those radii intersect. Objects, ideas, and people leak across the overlaps. When we see obsidian from central Anatolia turning up on an Ayan island, we can be confident it moved through multiple hands. What we can't say, at least not from the stone alone, is whether that movement was coordinated by specialists, overseen by powerful chiefs, or just the byproduct of routine visiting and gift-giving over generations. Several different social arrangements can produce the same archaeological pattern. A chain of small exchanges between egalitarian villages. Occasional long forays by mobile hunter-gatherers. More directed journeys by professional traders attached to emerging elites. All of these could in principle move obsidian from the same source to the same distant destination. The distribution data often can't distinguish between them cleanly. We can narrow the options by combining obsidian sourcing with other evidence: settlement size, house differences, burial practices, dietary patterns, genetic studies. Sometimes these lines converge on a plausible story. Other times they remain stubbornly ambiguous. A cluster of sites might share obsidian from a single volcano and similar house plans, yet show no strong signs of hierarchy. Another cluster might show the same obsidian pattern, but with big, elaborate buildings and marked grave differences. The material flows look alike. The social worlds behind them may not. It helps then to hold two thoughts at once. Obsidian distributions are powerful clues that people were connected across long distances both before and after farming. They let us trace the reach of networks that would otherwise be invisible. But they are not simple fingerprints of one kind of trade system, and they are rarely definitive by themselves. For any given path, a line from a central Anatolian source to a Levantine village, or from a Cappadocian volcano to a Cycladic island, there are usually several reasonable scenarios that could fit the data. The more we learn, the more those scenarios can be tested and refined, but they almost never collapse to a single unquestionable answer. In a way, that's part of the fascination. The obsidian trails invite us to imagine possible worlds, then force us to check those imaginings against small, sharp pieces of glass and the quiet chemistry inside them. They let us see the connection existed, while reminding us to be humble about exactly how it worked. The volcanic glass tells us that people did things that, from our perspective, shouldn't have been possible in a simple Stone Age world. It just doesn't always tell us in detail how they pulled it off. For all the lines we can draw on a map, there are still some very basic things we don't know. We can point to a village in central Anatolia and an island in the Ayan and say with quite a bit of confidence, this obsidian came from that volcano. We can estimate rough time ranges. We can even say something about intensity, whether a source was a minor curiosity or a major supplier. But we usually can't answer the most human questions. Who actually carried it? Were these journeys made by everyone as part of ordinary seasonal rounds, or by a few individuals with special roles? Were there people in the late Stone Age whose identity was tied to moving things and messages between communities, the way later merchants or messengers would be? Or did obsidian simply drift outward in the pockets and packs of ordinary foragers and farmers, never anyone's main job, always just part of something else they were doing? Then there's the question of rhythm. How often did these connections activate? Some obsidian links might have pulsed only every few years when groups gathered at particular seasonal meeting places. Others might have been part of annual visits between neighboring valleys. A few might have been one-off events, a small band moving house permanently, carrying their favorite tools with them, leaving a single faint trace that looks to us like part of a regular flow. And behind all of that sits the most elusive layer of all, the rules. We know from later small-scale societies that long-distance exchange is rarely a free-for-all. There are norms, taboos, expectations. Maybe obsidian was generally exchanged between affines, in-laws as part of marriage alliances. Maybe certain sources were owned by particular lineages who controlled access as a way of maintaining prestige. Maybe there were restrictions on who could travel where, or carry what, or give what to whom. The stone itself doesn't tell us whether a blade was a casual trade, a solemn gift, a bride wealth payment, or the outcome of a tense negotiation after a conflict. Those social meanings are mostly invisible to us. They are the mysteries that sit behind every tiny black flake. Part of the problem is that the archaeological record is deeply biased toward what survives. We're building our picture from things that last: stone, bone, fired clay. But a lot of the infrastructure that would have supported obsidian movement simply rotted away. If people crossed stretches of open water in the Ayan, they almost certainly did it in boats. Those boats might have been dugout canoes, stitched plank vessels, or skin-covered frames. All of them would have been made from wood, fiber, hide, resin. None of them would last very long once abandoned. They would sink, burn, or decay, leaving at best a few ambiguous stains and post holes in shoreline sediments. The same goes for the camps that would have dotted the routes. Hunter shelters on high passes, temporary shore camps on the way to an island, stopover sites in river valleys. These might have been little more than brush windbreaks, light huts, or simple hearths on exposed rock. A few seasons of erosion or a later flood could erase almost every trace. If they sit beneath modern cities, dams, or deep alluvium, we may never see them at all. Whole regions are still likely known. Survey work tends to follow modern roads, accessible landscapes, and politically stable areas. Mountain interiors, dense forests, intensively farmed plains, and some coastal zones remain under-investigated. It is very likely that key nodes in ancient exchange networks are still buried and unrecognized because nobody has yet gone looking in the right place with the right tools. Even when we do find the site, we rarely excavate all of it. We open small windows, sample portions. The obsidian that turns up in those trenches is just a fraction of what once passed through. And yet alongside these gaps, the tools for filling in the picture are improving. Every decade, sourcing databases get larger and more precise. More volcanoes are sampled in more detail. Tiny regional variants that once blurred together now separate cleanly under better instruments. What would once be labeled Central Anatolian obsidian can in some cases be narrowed to a specific ridge or flow. Analytical techniques are becoming more sensitive and less destructive. Portable XRF units can analyze artifacts in the field or in museum storerooms without cutting or polishing them, which means more pieces can be tested. Statistical methods for clustering and comparing compositions are more robust, letting archaeologists distinguish subtle patterns in mixed assemblages. Combined with better radioarbon calibration curves and basin modeling, these data can be anchored more firmly in time. New excavations are also changing the story. Broad, careful digs at small sites, not just at famous tells, are revealing workshops where obsidian was knapped in bulk, and tiny hamlets where just a few exotic blades arrived and were treasured for generations. High-altitude surveys are finding scatterings of obsidian on passes that connect valleys, hinting at forgotten routes. Underwater archaeology is starting to identify submerged shorelines and harbors from periods when sea levels were lower. If we imagine a future smoking gun for Stone Age exchange, it probably won't be a single spectacular find, but a chain of evidence that finally lines up. On the production end, that might look like a clearly defined workshop at the foot of a particular volcano. Heaps of core fragments, standardized preforms, diagnostic waste from large-scale blade production, all dated tightly to a specific window of centuries. Step away from the source, and we might find a series of intermediate sites, seasonal camps, small villages, shore stations, each with obsidian from that same workshop, showing consistent patterns of reduction. Perhaps the further we go, the more we see late-stage flakes and tiny tools, while closer in we see big cores and thick blades. At the far end, in a distant region or on an island, we could find a settlement whose obsidian assemblage matches the workshop's products almost one-to-one, both in composition and in the sequence of how the stone was worked. So I made me layered radiocarbon dates at all these sites would overlap closely, letting us trace a corridor active not just in space but in time, perhaps for only a few generations, perhaps for many centuries. Overlay that with other lines of data, similar house forms, shared decorative styles, parallel shifts in diet, maybe even genetic hints of intermarriage. And we would have something like a high-resolution snapshot of a particular network operating under particular social rules. We're not quite there yet. In most regions, the evidence is still patchy. The chronology is broad. The link suggestive rather than definitive. But the trajectory is toward finer grain, more sourced artifacts, better dated layers, more thoroughly surveyed landscapes. All of these increase the chance that one day we will be able to say with some confidence, not just that obsidian moved from this volcano to that coast, but that it did so most intensely between these centuries, via these kinds of sites, probably under these kinds of social arrangements. In the meantime, there is a certain calm in accepting that some questions will remain open. We can trace the glass. We can describe its roots in outline. We can sketch the possibilities for who carried it, how often, and under what rules, without pretending to know more than the evidence allows. Before we follow those trails into the broader question of what all this says about Stone Age society as a whole, a quick note. If you'd like to drift off with more stories like this, the Sleepy Time History book is available at sleepytimehistory.com. And there's a discount this week. It gathers episodes like this one into a quiet, slow, unfolding journey through the past. For now, though, the obsidian remains what it has always been. Small, sharp pieces of a much larger puzzle. They tell us that distant communities were in contact, but they don't fully reveal what those relationships felt like from the inside. They hint at rules, but they don't recite them. They mark paths, but they don't name the travelers. To get closer to that inner world, we have to step back from the individual artifacts and ask a bigger question. Taken together, what does all this glass say about the kind of world these people had built, long before cities, writing, or metal ever appeared? When we pull back and look at all the separate obsidian stories together, a particular picture starts to come into focus again and again. From Anatolian volcanoes to Aegean islands to Levantine valleys, we see the same quiet pattern. A stone that can be traced to a single patch of ground, turning up far beyond the horizon of its home. That sourcing work is our anchor. These aren't vague guesses about, probably from somewhere over there. They're compositional matches that point back to specific flows, specific domes, specific ridges. And when the same volcanic fingerprint appears at sites scattered across a landscape, sometimes separated by hundreds of kilometers, it tells us that however people were living, they were not living in isolation. The mechanisms that made this possible don't need to be exotic. Some of the distance can be explained by mobility itself. Hunter-gatherer groups in the Paleolithic already moved tens or even hundreds of kilometers over the course of a year or two, following water, animals, and seasons. If a band visited an obsidian source as part of its annual round, and then shifted its camp range a valley or two away the next decade, the stone could gradually drift outward just by people doing what they always did, carrying their tools with them. Beyond that, there is the slow, steady force of exchange chains. A core picked up near a volcano might be given, traded, or inherited at the next valley over. There it could be split, some pieces kept, others passed on. Over generations, without any single individual ever walking the whole route, the material could move remarkably far. Each step is small and local, but the sum of many steps adds up to long-distance connectivity. In coastal and island zones, some stretches almost certainly required water crossings. The presence of obsidian on islands that were never attached to the mainland and whose nearer sources lie across open sea implies some form of seafaring. Probably not grand voyages by our standards, more likely short hops along familiar shorelines, timed to calm weather and known currents. Still enough to carry glass across channels that no one could swim with a bag of tools on their back. Threaded through all of this is the social side. Alliances, marriage ties, visiting rights. The obsidian record only hints at these, but it is difficult to move stones repeatedly between distant groups without some kind of durable relationship. A trusted route might be held together by in-laws exchanging gifts at regular gatherings, by ritual partners obliged to visit one another, by neighboring communities who shared hunting grounds and water sources. The glass shows us that connections existed. The likely mechanisms are ordinary human ones we see in many small-scale societies: reciprocity, obligation, reputation, friendship. Taken together, the picture is not of a few heroic travelers leaping into the unknown, or of a rigid commercial system pushing bulk goods through fixed corridors. It is of a fabric of overlapping movements and meetings. People walking, paddling, resting, visiting, marrying, arguing, reconciling, and almost as a side effect, carrying shimmering black stone from place to place. There is wonder in that, but it is a quiet sort of wonder. We don't need to imagine global conspiracies or lost civilizations to be impressed. The measurable facts are already extraordinary enough that tens of thousands of years before cities, writing, or metal, communities were linked into wide networks where ideas, genes, and materials could travel much farther than any one lifetime's horizon. At the same time, it is worth staying close to what the evidence actually supports. We can say that particular pieces of obsidian came from particular sources. We can map broad corridors of movement. We can suggest plausible combinations of mobility, exchange chains, seafaring, and social alliances that would produce the patterns we see. Beyond that, the details remain open. Who led the journeys? How they told their stories about distant places? What songs they sang at shore camps before setting out? Those parts are likely to stay in the realm of careful imagination. Still, for anyone lying awake and listening, there may be something calming in knowing that deep time was not empty of connection. Long before our modern networks, people had already found ways to stitch landscapes together. Volcano to valley, valley to river, river to sea, island to island. A slow, patient web of contact, resilient enough that its traces still glint in the archaeological record. If you'd like to keep wandering through those prehistoric secrets, there's a Sleepy Time history book that gathers stories like this into a longer drifting journey. You can find it at sleepytimehistory.com. And if you'd like, read a bit before you fall asleep. And if this episode has kept you company tonight, it helps a great deal if you gently tap like, subscribe to the channel for more quiet histories, and leave a comment telling us where in the world you're listening from. Somewhere far back in the Stone Age, a stranger once handed a piece of obsidian to another stranger and turned them into a neighbor. In a small way, by sharing these stories, we are still part of that same long thread of connection. Heat, 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 heat.